Assalamu alaikum wa rahmatullah. This is our second video lecture of physics, and we are studying second chapter, and that's force and laws of motion. In the first video, we talked about the concept of force, and then we talked about the effects of force, and also we have talked about types of force. And we also mentioned some historical background, and we mentioned Aristotle's fallacy. So in this video, we'll talk about the first law of motion. The observation that proved Aristotle's fallacy wrong was made by Galileo. Okay? Because we have talked about the Aristotle's fallacy in the first video, and that was of course a fallacy, and that was a wrong statement given by Aristotle, and that was proven wrong by Galileo later on with his observation and experiments. So he was the first person who asserted that an object moves with a constant speed when no external force acts on it. Okay, if the external forces are not acting on an object, and if the object is moving with a constant speed, and the external force is not acting, the object will not stop. Okay, it is the external force. It's of course the external force which stops the object. That could be frictional force. Okay, that could be another external force which stops the object. If this external force was not present, that means the moving object will not be stopped at any point. So he arrived at the above conclusion by conducting a simple experiment with the inclined plane. And he proved that if the external force is not acting on an object, the object will not be stopping at all. So the experiment which was conducted by Aristotle is shown here, as you can see in these three images. In this experiment, two inclined planes were arranged facing each other, as shown here. These are the two inclinations, and they are facing each other. Okay, they are facing each other. He first kept the inclination of the plane on the both sides equal. The inclination on the both sides are equal firstly, and he released the marble from the left and observed that the marble is rolled down the inclined plane and climbed up the other and reached the same height. As you can see here, he released this marble from one end at one height, and it reached the other inclination to the same height. As you can see here, the heights are same. Okay, and then on decreasing the slope of the second plane gradually and repeating the same exercise, it was observed that the marble had to travel the longer distance. As you can see here, as we decrease this inclination, the slope, the marble will have to travel the greater distance now. As we continue this, the marble will have to travel the longer distances. And if the right side plane was made horizontal, okay, as you can see in the third diagram here, the marble is now made horizontal on the other side, right side. This means that the marble will have to travel an infinite distance to reach the same height. The unbalanced force on the marble in this case are zero. Okay, the unbalanced force as 0, because it will have to travel the infinite distance. This means that the unbalanced force must be 0 here. And this suggested, so this experiment suggested that an unbalanced external force is required to change the motion of the marble, as you can see here. This is unbalanced external force, as you can see here. This is not unbalanced, this is balanced force here, and its position is not changed. As you can see here, this height and this height are equal. Okay, as we unbalance this inclination, the motion of the object is changed. Okay? The motion of the object is changed, as you can see here. This is the first position, and the object has to travel the longer distance to reach the same height. This means that the unbalanced force, external force, is required to change the motion of the marble. But the second point here is that no net force is required to continue the motion. Okay, as you can see here, this motion continues. Okay, this motion is limitless. It has got no limit, because we do not know the final position here. This means that if there was no net force, the motion would have continued. The motion will continue. Okay, there is no if there was no net force, the motion of the marble would have continued. So, but this discussion which we have discussed here is a theoretical model. It's a theoretical model. If we talk practically, it's extremely difficult to achieve a zero unbalanced force. Okay, the zero unbalanced force is extremely difficult to reach out. And these were the ideas suggested by Galileo, which were later formulated into a law by Newton. And as we now know, Newton's first law of motion, and also called the law of inertia. This is also called the law of inertia. And it says that according to this law, or this is the Newton's first law of motion, it says a body remains in state of rest or uniform motion. A body remains in state of rest or uniform motion in a straight line unless an external unbalanced force is applied on it. If there was no external unbalanced force, the body will remain in its state of rest, or it will maintain its uniform motion if there was no external force. This means that external force is important to change the state of rest, or to change the uniform motion in a straight line. And this first law of motion gives the definition of inertia. Okay? And the definition of inertia is that property of a body due to which it resists a change in a state of rest or uniform motion. Greater the inertia, greater will be the resistance offered by the body to change its state, and greater will be the force required to bring a change in its state of rest or uniform motion, as you can see here. As the mass is greater, this means that the greater mass object, the object which has got greater mass, that will resist more powerfully as we apply the force on that object. If the object which has got greater mass is at rest, we will have to apply the greater force to move that object. Okay, and if that same object which has got greater mass is moving, we will have to apply the greater force to stop that object. And if on the other hand the object has got lighter mass, and in that case we will have to apply the lesser force, or the very less force to move that object or to stop that object if that object is moving. So the greater the mass, greater is the inertia. Okay, and this inertia is the property of a body by which it resists a change in a state of rest or in state of uniform motion. So I can say the mass is the measure of inertia. Okay, mass is the measure of inertia. This means that if there is greater mass, there will be greater inertia, and if there is lesser mass, there will be lesser. Basically, there are three types of inertia. First one is inertia of rest, and second one is inertia of motion. Third one is inertia of direction. Let me talk about first inertia of rest. The inertia of rest is the tendency of a body to remain its position of rest. Okay. For example, as you can see here, a person staying in a stationary bus falls backward, as it's obvious here. Okay, this happens because when the bus suddenly moves, the lower part of the body, that means the foot of a person, begins to move along with the bus, while the upper part of this body continues to remain at rest due to inertia of rest. As a result, the person falls backward. On shaking the branches of trees vigorously, the fruits fell down. Okay, the fruits fall down. This happens because as we shake the branches, the force applied on them brings them in motion. But the fruits tend to remain stationary due to inertia of rest. As a result, get detached and fall down. In the third example, if an index card is placed on the top of a glass with a penny on top of it, the index card can be quickly removed. As you can see here, the index card gets quickly removed while the penny falls into a glass. Because a penny has a tendency to stay at rest due to inertia of rest. As you can see here, it's clear that penny has got more mass. This means that more inertia. This means that it will have a more tendency to maintain the state of rest, and this index card has got less mass and less inertia, and this means a less tendency to maintain a state of rest. The second type of inertia is inertia of motion. Is the tendency of a body to remain in its state of uniform motion in a straight line. For example, as you can see here, the car and the driver had got the same speed. Okay, but this driver is loosely attached to this car. Okay, he is loosely attached to this car. The car suddenly stops as it hits this wall. It stops suddenly, but this driver had got the same speed at the which was the speed of the car, and he tries to continue its speed. He tries to continue its speed, so he comes out of the car. Another type of inertia is inertia of direction. Okay, it's a tendency of a body to continue to move in the original direction, or inability of the body by virtue of which it cannot change the direction of the motion by itself. For example, when a car takes a sharp turn at a high speed, the driver tends to get thrown to the other side due to inertia of direction. Okay, initially the car is moving along a straight line, But when it takes a sharp turn, the driver has the tendency to travel in a straight line direction due to inertia of direction, and hence he falls sideways in the opposite direction.